Today we are going to see problems on Lagrange multiplier method. Okay, start with the problem. A rectangular, write this one. A rectangular box open at the top is to have volume of 32 cc. Find the dimension of box that require the least material requires the least material for construction. So here we want to minimize the surface area. Okay. So here with the dimension we can take it as xy solution. Let the dimension of the boxes be box B X Y and Z. Then the surface area will be xy open at the top. So one side I am taking xy plus 2yz plus 2zx. And given volume is xyz, which is equal to 32. So we have to construct the function, Lagrange multiplier function, that is f of x, y, z, comma lambda, which is undetermined coefficient, that is xy plus 2yz plus 2zx minus determined lambda times of x, y, z minus 32. And this is your constraint. Constraint means under this condition, restriction or constraint. This function is called restriction or constraint. And the above one, which is the required you want to maximize, is called objective function. And this is the subject to constraint. Again, right? Subject to constraint. Okay. So first we want to find the derivative with respect to x. So f sub x will be is equal to here y and here will be plus 2z minus lambda y z. Similarly, fy will be is equal to x, that is differentiating partial with respect to x, y and z. So here y, right? So plus 2z minus lambda x y. Next f suffix z equal to z means 2y plus 2x minus lambda x y. Okay. Now equating to 0 all the three, so we get so from the first one y plus 2z minus lambda yz equal to 0. So from this y plus z 2z equal to minus lambda yz. So from this, or we can do it multiplying by x, that is also fine, and we can eliminate the lambda. Okay, we can do it minus lambda yz. So from this will implies 1 by z plus 2 by y equal to minus lambda. Similarly, if I take the second equation fy, we will get x plus 2z x plus 2z plus lambda xy, sorry, zx equal to 0. So from this x plus 2z equal to minus lambda xz, and this will imply dividing by xz we get 1 by z plus 2 by x is equal to minus lambda. Similarly, if I use the third equation, that is 2x plus 2y equal to minus lambda xy, 2x plus 2y minus lambda plus lambda xy is equal to 0. Right? Yeah, plus lambda xy plus will be there. From this we get 2x plus 2y equal to minus lambda xy. So dividing we get 1 by x, sorry, 2 by x, 2 by y plus 2 by x is equal to minus lambda. So if I use the first and second here to equation number 1 and equation number 2 and equation number 3, so equating 1 and 2 we get 1 by z from 1 and 2, we get 1 by z plus 2 by y equal to 1 by z plus 2 by x. So from this 2 by y is equal to 2 by x. So this will imply x is equal to 1. Similarly from 2 and 3 we get 1 by z plus 2 by x equal to 2 by x plus 2 by y. So 2 by x will become so 1 by z equal to 2 by y. So y is equal to 2z. Substituting this in the volume that x, y, z equal x, y, z equal to 32, we get x and y is equal to x and z equal to y by 2. So x is equal to y is equal to 2z. So the place of z I will get x by 2. So this is equal to 32. So x cube is equal to 16. Sorry, 64. Multiply this side. This will imply x is equal to 4. From this the dimensions are x is equal to y is equal to 4 and z equal to y by 2, which is equal to 2. Therefore the dimensions are 4 comma 4 comma 2, and the minimum surface area, that is a subjective constraint. That is the thing we require. Minimum surface area is xy plus 2yz plus 2zx, so which is equal to 16 plus 2 into 4 into 2 plus 2 into 2 into 4. So everywhere it will be 16 plus 16 plus 16, which is 32, 48 square units. That is the minimum surface area. But the condition of the volume is 32. Okay, thank you.